Alright, so today we will be covering section 1.5, which is a review of exponential and logarithmic equations. Exponential and logarithmic functions. My mistake. We will also be talking about some equations as well. That's why that word was on my mind. Apologize for that. Alright, let's start with a definition, and this is defining what an exponential function is. Definition. Any function of the form f of x equals b to the power of x, where b is some positive number, and b is not equal to 1, is called an exponential function with base b and exponent x. So the reason we say b cannot be equal to 1 is because let's see what would happen if it was. So let's say I had the function f of x equals 1 to the power of x. Well, think about it. No matter what I plug in here for x, no matter what it is, it could be 1, it could be 10, it could be 100. No matter what I plug in here for x, I'm always going to get a 1. So the reason we don't want our base to be a 1 is because if it was 1, it doesn't really tell me anything I didn't already know, right? It's just a 1, which is just a flat line, doesn't help us out. So that's why we say b cannot be equal to 1. Because if it was, then it would no longer have the form of having a power, okay? All right, so let me talk about what the distinction is and why we care about these, okay? So let's think about a function we have seen before. Like, let's look at f of x equals x squared. F of x equals x squared. Here, I'm going to be plugging in numbers for the base, right? So that as I plug in stuff, I would get like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. I'm plugging in stuff for the base, and my power is always 2. And we've already talked about how the graph of that is a parabola like this. But let's look at a function like this new type, like 2 to the x. In a function like this, I already know what the base is, and I'm going to plug in stuff for the power. So now I would have like 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. I want to plug in stuff for the power. Let's see what happens to that graph. Okay. All right. 2 to the first would be 2. 2 squared would be 4. 2 to the third would be 8, which would make it really high. 2 to the fourth is 16, which makes it really high. So this graph looks something like this. So the reason these are so cool is because they grow really quickly. Okay. These functions grow really quickly. And so that is why these are so cool, okay? There is a special base I want to look at that I could possibly have in an exponential function. And that is called the natural base. The natural base. So let's look at that. Definition. The natural base, which we call E, if you ever see an E, that's what we mean. The natural base E is the value that the expression 1 plus 1 over m to the power of m approaches as m gets increasingly larger. The natural base e is the value that the expression 1 plus 1 over m to the power of m approaches as m gets really big. So this might seem like a very random thing, right? What the heck is 1 plus 1 over m to the power of m? Well, this is actually something that pops up a lot, okay? We see this term in finance when we do compound interest. We see this term in biology. But I just all of a sudden forgot how to spell biology. There we go. Biology when we deal with population growth. And we see it a lot of different ways. So this is a term that comes up naturally. That's why that's the name of it. A lot throughout all math. And so as m gets really, really, really big on this term, it approaches what we call e. In fact, e is about 2.718282, and it can keep going forever and ever. So if you ever see an e in a math class, okay, what e is it is a constant. Just like how pi is, e is a constant, okay? And it's what happens as 1 plus 1 over m to the power of m as m gets really big, okay? E comes up a lot throughout calc 1 and 2, and E in fact does some really cool stuff, and so that's why we really like E. Okay, so that we are going to see E a lot in this class. All right, so one more thing, one more definition. The natural exponential function is f of x equals e to the power of x. So if you ever hear me talk about the natural exponential function, it is e to the x. Okay, so now that we know what an exponential function is, let's talk about what a logarithmic function is. Definition. The logarithmic function with base b is defined as log base b of x is equal to y if and only if b to the power of y is equal to x. So log base b of x is equal to y if and only if b to the power of y is equal to x. So let's talk about what that means, okay? So we know 2 to the power of 3 is equal to 8. We know that, right? Because 2 times 2 times 2 is 8. What a logarithm tells me is the power, okay? A logarithm is going to tell me what the power is. So I could rewrite this statement I know is true. I could rewrite this as log base 2 of 8 is equal to 3. Because what a logarithm tells me is what power I've got to raise my base to get that thing, okay? So if I ever saw log base 2 of 8, what that really is what power must I raise 2 to get 8? Well, we know that's to the power of 3. So log base 2 of 8 is 3 because that's my power, okay? A logarithm tells me what the power is. So just like we know 10 to the power of negative 2 is equal to 1 over 100. We know that. So I can rewrite that as a logarithm by saying log base 10, because my base is 10, of 1 over 100 is equal to negative 2. Again, because a logarithm tells me what the power is. Again, a logarithm tells me what the power is. So if I were to ask, for example, what is log base 5 of 125? What I really want to know is what power do I raise 5 to give me 125? Well, I know that's 5 to the third. So log base 5 of 125 is 3 because my power is equal to 3. Okay. So one more time, the logarithm tells me the power. It's looking for what the power is. Just like we did for exponentials, we have something that's called the natural logarithm, the natural logarithmic function. Is f of x is equal to ln of x. And what ln is a quicker way to write log base e. So if you ever see ln, what that really is log base e. Okay? Ln is log base e. One more time, just to make it super duper clear, the logarithm tells me what the power is. So keep that in mind. So we have some properties of logarithms that we need to follow. Here's some properties of logarithms. The first one says that if there is multiplication occurring inside of it, so like if I have log base b of ac, so if there's multiplication inside of there, I can write that as log base b of a plus log base b of c. So if there's multiplication happening inside of it, I can split it up and make it two terms by saying plus. If I'm dividing inside of there, so a divided by c, I can also split this into two, but I can do so by subtracting it. And then one more really cool one we are going to use a lot in this class is if you have log base b and then you have a to a power. So if there's a power inside of here, I can actually bring that power out to the front and make it r times log base b of a. So if there's a power inside of it, I can actually bring that out to the front. So what we are going to do now is we are going to use everything we have talked about so far, and we are going to solve some equations. Okay, we're going to take all the knowledge about exponential and logarithmic functions, and we are going to solve some equations. The first equation we're going to solve is the equation 4 to the power of x is equal to 64. 4 to the power of x is equal to 64. So this one isn't too bad. I just have to think here, okay, what power must I raise 4 to get me 64? So let's just go through them and see if I can find one that'll work. So 4 to the power of 1 is 4, so that isn't right. 4 to the power of 2 is like saying 4 times 4, which is 16, so that doesn't work. 4 to the third is 4 times 4 times 4. Well, 4 times 4 is 16. 16 times 4 is 64. So then I know I would have to do 4 to the third, so x must be equal to 3. Again, because that's the power that I must use. that one wasn't too bad, so let's look at some more examples that may take a little bit more thought. Let's do 5 to the power of x is equal to 2. So for that one, I would try and say, okay, is there a power I can raise 5 to and get me 2? Well, obviously there's not, right? Because 5 is greater than 2. So there's not going to be a power there I can do. So what I'm going to do is I'm actually going to use my logarithm rules, and I'm going to see if there's something I can do there. So I'm solving it for a power. Well, if I look at my log rules, I see, okay, if there's a power inside of the logarithm, I can bring it down front, right? But that's only if it's inside a logarithm. This is not. But what I can do is I can take the log on both sides there, in which case then it would be, right? I can pick whatever log I want to. I could do log base 10. I could do log base 8. It doesn't matter. Since it doesn't matter which one I do, we always just say let's do ln, simply because that's less stuff I've got to write down. So let's do ln of 5 to the x is equal to ln of 2. Now that the power is inside of a logarithm, I can bring it out to the front. So I can bring my x down to the front and make this x ln of 5 is equal to ln of 2. So now all I've got to do to solve that for the x is divide by ln of 5. So x is equal to ln of 2 divided by ln of 5. Let's do one with a little bit more terms. A few more terms. E to the power of x plus 6e to the power of negative x equals 5. So this one just looks like a mess. There's a lot of terms there. There's a lot of stuff that's happening. First thing I can see, though, is that I have e to the negative x. We know from the rules of exponents that that's like saying 6 over e to the x, which would make this really hard, right? So we don't really like that a whole lot. So what I can actually do is multiply everything by e to the x so that I don't have to deal with this. So e to the x times e to the x, our bases are the same, so I can just add the powers, make that e to the 2x, plus 6 times e to the negative x times e to the x. The bases are the same, so I just add the powers, but negative x plus x is 0, so that cancels out. So all I have is a 6. And then 5 times e to the x is just 5 e to the x. Let's move everything to one side and see if that helps me out. E to the 2x minus 5 e to the x plus 6 equals 0. This looks kind of like an equation that's quadratic, right? Because here I have e to the x, and over here I have e to the x squared. So I can treat this like a quadratic equation and say, are there any factors of 6 whose sum is equal to negative 5? And I can see I can do negative 3 and negative 2. So e to the x minus 3 times e to the x minus 2 equals 0. I factored it out, so set each factor equal to 0. Add 3 on that one, e to the x equals 3. Add 2 on that one, e to the x equals 2. And then now I need the power, right? So just like we did on the last one, I can take the natural log on both sides. I can bring my power down to the front, so x times the natural log of e equals the natural log of 3. But remember, we said ln is log base e, right? So ln of e is just a 1. So I can just make this 1, which gives me x equals ln of 3. Do the same thing over here. Take the natural log of both sides. Bring my power down to the front. X ln of e equals ln of 2. But just like we said, since ln is log base e, ln of e is a 1. So that cancels out. And we're left with just x equals ln of 2. So for this one, we get natural log of 3 and natural log of 2. Have a few more examples I want us to work through. Let's do ln of 1 over x is equal to 4. So remember, a logarithm tells me the power. So since I know ln is log base e, I know my base is e and my power is a 4, right? Because a logarithm tells me what the power is. So my base is e, my power is 4, and I should get 1 over x. So now I just have to solve that for x. So multiply both sides by x to cancel it out right there. So I have x e to the 4th equals 1, and I'm solving it for x, so just divide by e to the 4th. So x is equal to 1 over e to the 4th is like saying e to the negative 4th. X is equal to e to the negative 4th. Next example, log base 10 of the square root of x plus log base 10, forgot the g, sorry, log base 10 of x, and we're saying that's equal to 2. So the good thing about the last one we did right here was that on the left side I just had 1 log, right? But on this side I have 2 of them. In order to do like what I did up here, I need only 1 log over here. Since I have 2 logarithms and I'm saying plus, I can use one of our logarithm rules right here where I said whenever I have plus, I can do that when I'm multiplying in here, right? So using that idea, I can rewrite this as 1 logarithm and multiply. So that's the square root of x times x equals 2. So now, just like I did over here, I know my base is 10 and my power is 2, and that's going to be equal to, let's try to find a better way to rewrite square root of x times the x, because that's just a mess. Remember, square root of x is like saying x to the 1/2 times x, and just an x is like saying x to the 1st. Since I'm saying times, I can add those up. 1/2 plus 1, get a common denominator, and you see that's 3 over 2. So we know that should be equal to x to the power of 3 over 2. Work this out more. 10 squared is 100, so that's 100 equals x to the 3/2. To get rid of the 3/2, we're going to raise everything to the power of, flip it, 2/3. So x is equal to whatever 100 to the power of 2/3 is. Whenever you ever get to stuff that's like this, where it can't really be rewritten, you could just leave this, right? Because 100 to the 2/3 really means the cube root of 100 squared, but that's not really a clean and clear thing, so just leave it just like that. All right, I have one more example. ln of 2x minus 3 ln of x squared equals 0. All right, so just like on the one we just did, I have two logarithms here that I want to make 1. Okay, I want this to be 1 term. So I've got to see what I can do to do that. Okay, so notice I have a 3 out front. Okay, remember we said a number out front came from the power. That was another one of the rules we had. A number out front came from the power. So I can bring this in and make it the power. So I would do x squared to the 3rd, which is x to the 6th. So this becomes ln of 2x minus ln of x to the 6th equals 0. And then I can make this 1 term. Since they are subtracted, I can divide. 2x over x to the 6th equals 0. I can reduce this. Since there's an x up here and 6 of them right here, I can make that 2 over x to the 5th. So now I know my base is e because it's ln, so that's base e to the power of 0 must be equal to 2 over x to the 5th. E to the 0 is a 1, so that's 1 equals 2 over x to the 5th. Multiply by x to the 5th to cancel it out. And you end up with x to the 5th equals 2. And so raise everything to the 1/5 to cancel it out over there. So x is equal to 2 to the power of 1 over 5. All right, so I think that is going to do it for our review of exponential and logarithmic functions. And so that is going to be the end of our review of pre-calculus stuff. Remember, if you ever need any help with any part of this, please just let me know. I will be happy to help out. I look forward to starting chapter 2, which is where we are actually going to get into the calculus stuff. I cannot wait. Y'all are going to have a great time with it.